Hello and welcome everybody to our last weather briefing in 2015, to our December weather briefing. Some of you are probably new to our weather briefing, so I'd like to introduce myself. My name is Liliane Hofer and I'm working at the ZAMG, at the National Weather Service in Austria. Some of you might already know it. I'm not sitting in the headquarters of the ZAMG in Vienna, but I'm sitting at a regional center over here in Salzburg. So here we have a nice overview over Europe, a map. So could you please take your star and show me where you're sitting at the moment? Okay, very nice. Thank you very much. So people from all over Europe, from the west, the south, the north, very nice. So let's start with the meteorology. So this is the last weather briefing in 2015. I've already mentioned that, and that means that it's the Christmas weather briefing. So as Christmas comes nearer and nearer, let's take a look at this satellite image, the visible 0.6, and take your stars, take your pointers, and today we will go on the search for snow. So if you think you see some snowy patches, some snowy areas in these satellite images, what do you think? Can you even see snow with the help of the visible 0.6? Whatever you think, please take your star and put it to the region where you think you can see snow with the help of the visible 0.6. Okay, I see one star at the Alps, another one. Okay, it's always a good bet. Yes. Okay, the Pyrenees. I can see your point. Another star. Okay, quite far up in the north. So you see, it's not that easy. Everything is just gray or white. So you have to know the orography to know whether it's snow or it's clouds or anything like that. But yeah, I think you've actually found some snow with the help of the visible 0.6 nevertheless. Let's take a look at the next satellite image, the next satellite product. I have here the natural Colour RGB. So probably now it's a little bit more easy. It's the same question or the same task. Please take your stars, take your pointers, and again, show me where you think you see snow, or show me where there's actual snow. Should be a lot easier now. Okay, again, the Alps and the Pyrenees, the North, Finland. Okay, nice. So I see more stars in different regions now. So I think the point is quite clear. The natural Colour RGB gives you is a lot more helpful than a visible satellite image for detecting or monitoring snow. Okay. Last but not least, I have another satellite product to show. It's the so-called Snow RGB. So now it shouldn't be too tricky what the main purpose of this RGB is. So the task is the same. Please take your star, take your pointer, show me regions where you actually can see snow with the help of the satellite image. I don't mean where you think there is snow or where you know there is snow, but where you can really detect it with the help of this satellite image. Okay, I see some new, let's call them snowy areas up here in the north. This region was also not indicated before. The Alp ridge, yes, you can see it quite clearly now. Okay. So in any case, you're wondering the images. Okay, continue putting your stars to the snowy areas while I'm talking. So I hope you're not irritated by the date. These satellite images were all from yesterday, 9 UTC. And there is one reason, because today it's very cloudy all over Europe. It's some frontal system coming in from the Atlantic, as we will see later. There are some foggy patches. So I've chosen the satellite images from yesterday, so you can actually see some snow. So we've seen now the visible image where you can see the snow, but you have to know that it's snow. Otherwise, you might think it's just a cloud because all is whitish. The natural color RGB is more helpful, as snow has a certain color, cyan, but the problem is that also ice clouds have the same color. So again, you have to know where are mountains, where was it cold, things like that. And then in the end, we have here the Snow RGB, where snow has a really distinct color. It's this reddish color over here you've seen over the Alpine Ridge, or you can also see it a little bit here over the Pyrenees, the Dinaric Mountains. And this really indicates snow because thick ice clouds have another color. So now you have done a lot, and here is now the complete solution. This is a chart of the snow height, of the actual snow heights from today in the morning. I took it from the weatheronline.de homepage, .de, and here you can see snow in the Alpine region. You can see some snow also in the Fichtelgebirge. We haven't seen it on the satellite image. I think we have seen an orange dot here over the, I think it's the Balkan Mountains, and we had lots of snow far up in the north. So just that you know, all these snow measurements are connected to mountain stations, and most of these snow observations are really connected to lower lying regions. So that means that in this part of Europe, there's nearly no snow in the lower lying regions, whereas here we have at least a little bit of a wintry landscape over here in this region. But let's come back to the detecting of the snow with the help of satellite images. So, I mean, this is more a rhetoric question, but you can nevertheless put a star to the answer you think that is right. So, which satellite image, which satellite product would you choose for monitoring snow? The visible, the natural color RGB, or the Snow RGB? And I think, yes, I think it's, as the name implies, it's the Snow RGB. Yeah. Let's take a closer look at the Snow RGB, respectively the natural color RGB. I mean, the natural color RGB is also a great help because snow has a very distinct color, this cyan. But the problem is that not only snow has this color, but also ice clouds. So here you have the recipe for the natural color RGB, and what do you think? Snow has the color cyan. So you have here the three color beams, red, green, blue. What do you think? What is the proportion of these color beams so that in the end you have the color cyan? Do you think it's half of the red beam, half of the green beam, half of the blue beam? What do you think? So you can now put your stars to where you think, to which proportion the color beams are used. So 0% or 100%, what do you think? What do you need that get the color cyan? Okay, this would be red, the first one, 100% red, 0 blue, 0 green, it would be red. Okay, it gets a little bit difficult now. In the end, we might get the right solution, but probably not on purpose. Okay, I think we stop at this point before I lose the overview. You get the color cyan if you have absolutely or nearly no red contribution, and a full green contribution and a full blue contribution. Then you get the color cyan. That means in the natural color RGB, you see snow if there's nearly no contribution from the near-infrared 1.6, and that's due to the fact that the near-infrared really absorbs a lot, or the reflectivity for snow is really low in the near-infrared 1.6. So there's high infrared in the green, on the green and on the blue beam, and so cyan, but also ice colors appear, snow and also ice clouds appear in this cyan color. So you can see snow, but you cannot tell the difference whether it's really snow or an ice cloud. On the other hand, the Snow RGB, let's just change the pointer. The Snow RGB, here you have the recipe. It's quite similar. It's again the visible 0.8 over here and the near infrared 1.6. But instead of a third visible channel, we have the infrared 3.9 channel. And in this special case, you probably know that the infrared 3.9 has a solar component and a thermal component. In this special case, as we are also using visible channels, we use the solar component, so just the reflective part of the infrared 3.9. So you have seen snow appears in reddish colors. So in order to get the color red, I think I can answer these questions. You need 100% of the red beam and nearly or no green or blue proportion. But this is probably a bit more difficult, as you have seen thick ice clouds appear orange in the Snow RGB. And what do you think? What recipe do we need from the red, green and blue color green so that we end up with the color orange? It's quite tricky. Oh, okay. I think the first one who has answered this has already got the right answer. Wow, really a quick one. I think we can end now as the image gets quite confused with all the stars. So the first answer was 100% red, 50% green, and nearly no blue contribution. So that's how you get the color orange, and that's because you have, or snow has a really high reflectivity in the visible 0.8, a lower reflection in the green beam, and nearly no reflection in the infrared 3.9 channel. So that's the difference between thick ice clouds or ice clouds and snow in the Snow RGB. So always keep in mind, if you have the Snow RGB at hand, as the name implies, also always use the Snow RGB for monitoring or detecting snow. Otherwise, also the natural color RGB might give you a quite good hint if you're used to the local orography. So let's move on. We have seen, okay, that's just what I said. Just to sum it up again, no difference between ice clouds and snow. And here, snow is red, ice clouds appear orange. As I've shown you before, there's nearly no snow in wide parts of Europe. Just in the northern parts, there's really snow in the lower lying regions. So how does the overall weather situation look like? So that's the actual infrared 10.8 image from 6 UTC in the morning, overlaid with the absolute topography in 500 hectopascal. And yes, here you see Europe is getting the air mainly from the Atlantic region. So mainly Atlantic air masses are dominating the weather in wide parts of Europe. That means partly moist area, but also very mild air masses are advected. What more do we see? We see this nice frontal system over here with, wait a minute, this one with a nice cold front and a warm front, and this system might reach Central Europe until tomorrow. And even behind the cold front, the snow line lies around 1,800 meters, so nearly, yeah, only on the higher tops of the mountains there will be some fresh snow, but apart from that it will be mainly rain in connection to this cold front. So it's far too mild in wide parts of Europe. So let's take a quick look at the Airmass RGB. It's also from today's 6 UTC. As you might know, the Airmass RGB is consisting of the combination of several infrared channels, and also the 2 water vapor channels are used. And in the end, you have an image that shows you not only the clouds in these whitish colors, but the colors indicate what kind of air mass is prevailing. So these blue and violet colors are assigned for polar air masses, whereas these more greenish colors are assigned for warmer or even tropical air masses. And in this image you see very nice that the cold or the polar air masses are somehow north of this line, and south of this line it's warmer. You have these green colors, and I think this image is really similar to the snow height chart you've seen in the beginning, so that there's some snow in lower lying areas in this region over here, but nearly no snow in the south. So only in the higher regions, on the mountains, on the summits, there's some snow. But apart from that, mainly sunny or mainly mild weather conditions prevail in the southern or in Western and Central Europe, so to say. So is that normal? I mean, today's the 15th of December, so the meteorological winter has started, but not the astronomical. So is it normal, or are we just craving for snow because of all the Christmas ads and things like that suggest that we should have snow by now? But is it normal, or is it really too warm? And here we have the temperature anomaly chart. It's from the beginning of December to now. So from the 1st of December until the 14th of December, it's the anomaly. So you see all the yellowish over red to brownish colors show that it's too mild for the season, whereas the bluish green colors indicate too cold conditions. And you see that also in the northern areas where I've seen some snow on the ground over here, it's far too warm, it's far too mild, especially over Russia. We have a temperature anomaly of about +7, +8 degrees, which is really for a time period of 2 weeks, this is a really huge number. And so it's really too warm. So it's not just that we shouldn't have snow at this time of year, it's really far too warm, it's far too mild, and it's not a normal state of the atmosphere at the moment. And before I come to the outlook, to the Christmas outlook, so what will happen next? I will build up some suspense and hand the microphone now to Andreas, who will present our new ePort. And afterwards, I will tell you whether there will be White Christmas in your area or not.
Yes, thank you, Lily. Can you all hear me? Yes, fine. So that's me. And I will give you now a bit more technical presentation, because I'm going to speak about the new ePort. The ePort is the platform where you can combine satellite images and NWP fields and satellite products. And I have here the snapshots from the main page of EUMeTrain. And you have the pull down menu. Here it is pulled down. In fact, it's the same, just 2 items have been added, ePort and ePort Pro. So I'm going to present ePort now in the next 5 minutes. ePort Pro will be presented at another occasion. This is much more difficult to explain, and it is rather for courses and for training. So ePort, you just have to click on ePort and you get the main page. Be aware that the old ePort is still available. You can go to ePort Europe, South Africa, Middle East, and also the archive is still available and will be available in the future as long as we can maintain the system. But more and more we will switch to the new one. So before you see how it looks like, let me shortly speak about why we did the change. The support is ending of the old ePort. It was a former colleague of mine who did that, but he is not working here at our institute anymore, so we had to see for another system. The old system is not extendable anymore because of technical reasons. The satellite images were not in the full resolution. And we also wanted to have something which makes use of the web mapping technology, something which didn't exist 10 years ago when we started with the old ePort. We get constant upgrade and support because it's a professional company who is now who has programmed the ePort, and maintenance is also much easier. So the system requirements, maybe I should say a few words about it. We tested it with different versions of Internet Explorer and with Firefox and also with Chrome, and there seem to be no major problems, no major issues. I, for my personal feeling before, like the Firefox most, because sometimes my Internet Explorer remembers old settings and I did not know how to overcome them. But I have a very old Internet Explorer. It's the version 8 and it's really outdated. And what I also recommend is to have a PC with at least 2 GB of memory, because the flash uses more than 1 GB, and disk is the memory is always swapping on the disk, and this slows down the system very much if you have less than 2 GB of memory. So let's have a look how the system looks like. Lily already showed some slides from the new ePort. That's what you get to see when you click on ePort. You have the 5 different regions. They can be modified, of course. You have here the RGBs and images, and that's new. Images combined always with some numerical model field. Here you have the actual image, which is going to be shown. This is the Airmass RGB for the moment, and here you see the overlays, some contour lines, border lines, and geographical lines. On this place here, you can select the date of the image you want to have. So this is the dust RGB. All the RGBs you could find in the old ePort are also present in the new ePort. If you want to have more of the satellite image and less of the menus, you can click them away by clicking here. They can slide out and slide in if you want to see them, but you can also display the whole satellite image on the screen. That makes a better view of the numerical fields and of the satellite image, of course. So here, for example, you have the thermal front parameter and the infrared image, 10.8 micrometer. It's a combination of both. Here you have the model run. It's from Sunday, 12 UTC, and here it's a forecast. Of course, it's not the analysis, but you can never choose a forecast. That means as soon as it's 6 UTC on Monday, you have this field, but not before. So it's only a training system and not a prognostic system. You can modify this page by clicking away the satellite image. You click here and then the satellite image is gone. If you click here, then the NWP is gone and satellite image stays. So it's quite flexible. even though these parameters are always combined, temperature, advection with some satellite image, you can easily look at only one of both parameters. This parameter here is the temperature, for example, and that's something which is new compared to the old ePort. You have the possibility here to switch between different levels. So all the main pressure levels are reflected only for the basic parameters, and these are geopotential height, the temperature, and humidity, for example. Temperature advection, also derived fields are available on the main pressure fields. So it's quite easy to use. You can pan, that means you can displace the image by clicking this button. You can also zoom in. This is just the process of zooming in. You click on the image here and then you draw the region you want to look in. Here you have the wind. You see the green arrows at 500 hectopascal. And if you zoom in, next image, you will see that there's much more information in more details. This was not available in the old ePort, but that's the advantage of having a web map service. The more you zoom in, the more details you get out of the numerical field. So I have zoomed in here. You see that you have much more green arrows. So you can easily change between the regions. What you just have seen is the Europe polar stereographic, and now you have South Africa in another cylindrical projection. So this is done quite rapidly. And once you have selected a field, for example, wind, it's kept. So if you change the geographical position, the numerical fields you had are kept. So wind here at 500 hectopascal. The same is if you change the frame, you move from one day to another, the numerical field will stay the same. So you have the synop stations worldwide. All the data are there. The more you zoom in, the more synop stations you will get. You have also radar. This is the Opera radar. Unfortunately, Opera is only for Europe, so if you go to South Africa or Middle East, Opera will not be available. But for the European frame, it is available. So it's very similar to what you know from the old ePort. This is the polar region. This also existed in the old ePort. But be aware that similar to the old ePort, these are the overpasses of the ABHR, of METOP instruments, the infrared. And it's from the last 6 hours. So we are collecting here from 0 UTC to 6 UTC. We are collecting the overpasses and put them over each other, and then you have kind of blended field that you can see here. But it's similar than the old ePort. So let's come back. I want to invite you to use this to get used to that. It's a little bit different, but hopefully you will easily learn it and see the advantages of the new ePort. Just click here and the new ePort will appear. Nevertheless, you can also use the old ePort for the time it is still running by clicking here. So thank you very much, and if you have questions, don't hesitate to contact me either by clicking here on info@EUMeTrain.at or by directly sending me an email. I will type my address in the text chat. Yeah, thank you very much.
I will just continue with my presentation and show you very quickly the Christmas outlook. So if you remember, something like 15 minutes ago, I ended the first part of my presentation with this image where you see that December started really far too warm. So until half of the month, the temperatures were really far too mild. And so let's take a look at the outlook. So I've show you now a picture of the temperature anomaly from the ECMWF model. This time it's a forecast. The previous image was really analysis. Now it's a forecast, and it's a forecast from next Monday to next Sunday. So a forecast for the next week, for the Christmas week, so to say. And you see that temperature pattern stays more or less the same. So most parts of Europe, not to say whole Europe, I mean, okay, Iceland is on the colder side, but most parts of Europe remain far too warm, far too mild, and I think as this is an image for the next week, I think the chances for White Christmas at least in lower lying areas or in areas where there's no snow at the moment don't look too good. I mean, this chart, it just says the temperature conditions for the whole week, so probably the first 4 days I have, 20 degrees, and the rest of the week is around 0 degrees. Something like that can have the same result as this, so chances are not zero, but doesn't look too good for a cold and white Christmas Eve. And let's take a quick look at the deterministic solution the models have, or the models show right now. So that's the ECMWF model. It's the deterministic solution, so it changes from day to day. I have to admit that on Sunday there was one solution where you had really outbreak of these polar air masses, so not so much a westerly stream, but on Sunday the solution was more like a northwesterly stream, and as cold polar air is building up in the north of here somewhere, so there might be some chances that there will be a cold air outbreak, but you need a northwesterly stream and not such a westerly stream as this deterministic solution from today's model run suggests. This is the ECMWF, so if you take this for true, then on 24th of December, the weather will continue like it is now with some low stratus, some cloudy conditions, but doesn't look too good for snow for wide parts of Europe. Quite similar image is drawn by the GFS model, the American model. Also here you have really cold air masses in the north. The minus 30 isotherm is somewhere like here, I think. And just as a rule of thumb, I would say that you need minus 30 degrees, something like that, in 500 hectopascal, like this is shown here, to have snow on the ground. I know the temperature in 500 hectopascal is no good measurement for the snow line, but I didn't want to upload the images of a deterministic model run that might change from day to day. But you see, it's mainly the same image. Great parts of Europe remain in the more westerly or even southwesterly stream, so looks like a mild Christmas, at least in this solution. And so that's nearly the end of the weather briefing, and I would like to end it with this image. You probably know that the Austrian Weather Service has also a weather observatory in the Alps on a summit in 3,000 meters height. And this was Christmas. This was last year's Christmas on this observatory. You see there's nearly no snow in the valleys, but at least the Somblick Observatory has some snow and some nice pink colors. And so you see this observatory is in 3,000 meters height, and the temperature was just minus 4 degrees, so also far too mild. And I think we will have a similar Christmas this year, but let's see, it's still 9 days to go and things can change, especially the forecasts in 9 days. I would like to thank you all for taking part in this weather briefing, but also for taking part in all the other weather briefings and also in all the other EUMeTrain courses or event weeks. And I hope you will join us also in the next year. We have some good event weeks planned, some courses. Our weather briefings will continue. The next weather briefing will be led by the Croatian Weather Service, the HMZ, and will take part on the 14th of January. Again, in the afternoon, that means at 1 UTC. I hope you will be there, and I wish you all a Merry Christmas and a Happy New Year.